All right, so today we're going to do the last set of identities on our yellow sheet. Okay, so these are called the half-angle identities, and you'll notice that they're a little bit messier, and that is because they have that square root in there. So let's take a look at these last ones. I'm not going to prove them today, just to save time on the video, but when I get back, maybe I'll show you where they come from. But essentially, they just come from the double angle formula, but resolved. So if you take that double angle formula that you see over there, the cosine of 2x equals 2 cosine squared x minus 1, and you resolve it, then you end up with the half angle. And so that's why you end up with a square root, because to undo that square, you get a square root, okay? So it's the same idea as we've done before. And so let's say you wanted to find the cosine of 15 degrees. So up until now, the only way to get 15 degrees was we actually learned that you could do like 45 minus 30, right? So you could use a difference formula. But we're going to look at it today using a half angle formula. So another way to do this would be say, well, I could say that's 30 degrees divided by 2, right? That's another way to get 15. And so if we're using the cosine formula for half angle, so we look at the formula sheet and it says, okay, the angle divided by 2 is plus or minus the square root of 1 plus the cosine of x divided by 2. So notice then here that in this case, x, right, is our 30-degree angle. So we're using an angle, again, that we know, and then we're writing that out using our formula. So the cosine of 30 divided by 2, which would be 15, is plus or minus the square root of 1 plus the cosine of 30, right? That's our x value, divided by 2. And again, the reason we're doing that is because the cosine of 30 is something that we can actually evaluate. So the cosine of 30 is the square root of 3 over 2, all over 2. Now, one thing about the half angles that makes them a little bit messier is that you'll notice it's got this plus or minus out in front. And so unlike all the other formulas where the positive or the negative just works out, for this formula, you have to choose which one, okay? And so to do that, you come back and you look at the angle you're dealing with, right? So the 15 degrees is in quadrant 1. So we know that in quadrant 1, cosine is positive. So for this particular problem, we're just going to pick the positive, right? So the only thing is you just have to think about whether or not you want to keep the positive or you want to make it negative based on your quadrant, okay? And so then we've got the square root of, and then what I tend to do, the easiest thing I think to simplify this is if underneath this radical I multiply by 2 over 2, that way underneath, right, I'm going to get 2 plus, here the 2's would cancel, so radical 3 all over 2 times 2 is 4. And so sometimes what we will do then is say, well, then the top is the square root of 2 plus radical 3, and the bottom, the square root of 4, is 2. And so there is the exact value of the cosine of 15 degrees, okay? If I was doing 165, again, there's different ways to do it, but using the half angle, I could say that this is 330 divided by 2, right? So 330 degrees divided by 2 is going to give me 165, right? So now I use the half angle for sine, and I think what's kind of interesting is notice that the half angle for sine still uses cosine in the formula, right? So notice that on your formula sheet, both the half angle for sine and cosine have cosine in the formula. The only difference is that one is positive plus the cosine, the other is minus, right? Again, we have to decide whether to make it positive or negative. So we look here at our angle. So 165 degrees would be in quadrant 2, right? So sine is going to be positive there. So we know we're going to pick the positive one, right? And so then I just plug in. So I got the square root of 1 minus the cosine of 330 all over 2. So the cosine of 330 is an angle that we know, right? So we could 330 is going to be all the way over here with a reference angle of 30. So this is going to be root 3. This is 2. This is 1. So my cosine is radical 3 over 2 all over 2. I can do the same thing I did before, multiply by 2 over 2 underneath that radical. That's going to simplify things down for me. So I've got 2 minus radical 3 all over 2 times 2 is 4. The square root of 4 is 2. And I get a very similar answer to my last problem. Right? Okay. So that's one way we can use the half angles. Another way we can use the half angles is if we have a triangle that gives us theta, right? Then we know from this triangle, like we know things like the sine of theta is 3/5, right? We know the cosine of theta is 4/5. And so the question though is, well, what about if I took the angle theta and I cut it in half, right? And so just cutting the angle in half, cut the sine ratio in half. And the answer is no, right? Instead, we know that if I take the angle and I cut it in half, it actually takes the square root of 1 minus the cosine of the angle all over 2, right? Much more complicated. Unfortunately, it doesn't just cut it in half, right? So again, though, this is an acute angle here because it's just in a little right triangle. So we know then that for this particular problem, again, it's going to be positive. So we just pick it. So we know it's positive. And then we got 1 minus the cosine of the original angle theta. So the original angle theta had a cosine of 4/5. Right, so this would be 4/5 all over 2. And so technically that's it, but we typically like to simplify. So again, I would multiply in here by 5 over 5. And so that's going to give us the square root of 5 minus 4 all over 10, which is the square root of 1/10, right? Which you can leave as that, or you could write it as 1 over radical 10. It really doesn't matter. And so again, here we've got the the cosine. We're doing cosine this time. So the cosine of theta cut in half is again going to be positive because this is an acute angle, but this time it's 1 plus the cosine of theta all over 2. So the only difference now is that it's going to be 1 plus 4/5 over 2. So multiplying by 5 over 5 actually gives us the square root of 9 over 10, right? 5 plus 4. Which, again, if you wanted the square root of 9, you could say is 3, and this is radical 10. So, and I don't care if you rationalize. And so here, the square root of 1 is 1, and then we've got the radical 10. So you could do that, okay? Now, what's interesting for tangent is notice that it has a couple of options you can choose. So for tangent, we can pick a couple of different options. It's totally up to you. And so it's the sine of the angle divided by 1 plus the cosine of the angle, okay? But another thing we could do is another way to get tangent of theta cut in half is to take the sine of the half angle and divide it by the cosine of the half angle. We can actually use our old trig identities. And the reason that's helpful is because notice we already have the sine and the cosine already. So another way to do this is we can just say, okay, well, let's just put the sine, which was 1 over radical 10, all over the cosine, which is 3 over radical 10, and I just get 1/3. So that's a quicker way to do it, right? But another way to do it is come up here and use what we know. So the sine of the original angle is 3/5 over 1 plus the cosine of the original angle is 4/5. And so hopefully we get the same thing. So again, if I multiply by 5 over 5, I get 3 over 9, right? Because this would be 5 plus 4, which is indeed 1/3. Okay. All right. So now for this last one, I actually just want to talk a little bit about kind of some clever ways to do this one. So notice that we've actually already found the sine and the cosine. So we could just here say, well, this is 2 times. So the sine of the angle cut in half was 1 over radical 10. And the cosine of it cut in half was 3 over radical 10. So when I multiply that, this is like over 1, so I'm going to get 6. And then radical 10 times radical 10 is 10. So I get 3/5, right? Or, look at another clever way to do this. What if we recognize that this is actually, notice 2 sine of theta cut in half times the cosine of theta cut in half is our double angle formula. Right? Our double angle formula says 2 sine x cosine x is the sine of 2x. So that means that this is actually then the sine of theta cut in half times 2, which is the sine of theta. And if I go all the way back to the beginning, sure enough, it's the sine of theta. So that's kind of a cool way to verify one of those identities. All right. Let's take a look here at one more example where we're having to now think about where the angle is, right? So we've seen these problems before where they've told us, hey, theta is an angle somewhere between pi and 3 pi over 2, okay? So if I were to sketch theta, then I know that theta, right, is somewhere down here in the 3rd quadrant. So there's theta, right? And it has a cosecant of negative 13/5. So that means it has a sine of negative 5/13, right? So this is going to be negative 5. This is going to be 13. So then the Pythagorean theorem, this is one of our Pythagorean triples. So we know that this is a 5, 12, 13. So this is negative 12 over here, okay? Now, what you need to be careful of on these problems is, again, that plus or minus, okay? So if I want to find the sine of the angle cut in half, again, I go up, there's a formula. So I pull out my sheet. It's plus or minus the square root of 1 minus the cosine of the angle divided by 2. And so if I go in here, then that's going to be the square root of 1 minus, so the cosine, so coming back to my original angle theta, right? The cosine is going to be negative 12/13 over 2. Now, the question then is, which of these should I pick? And so what we have to be careful of here is that what we have drawn a picture of is the angle theta, but what we're evaluating is theta cut in half, right? And so if I took this angle theta that's down in quadrant 3 and I divided it by 2, then what's going to happen? So if I think about if I were to take this inequality and I divided theta by 2, then that means I would also be dividing pi by 2, and I'd be dividing 3 pi over 2 by 2, which would be giving me 3 pi over 4, right? So if I divide all of these by 2, now I find out where theta cut in half is. So theta cut in half is between pi over 2 and 3 pi over 4, so theta cut in half is somewhere up in here, right? So there, that pink angle is theta cut in half. So that means that theta cut in half is actually in quadrant 2. So that means that down here, when I pick the sine, I want to pick the positive value, right? Then we're in quadrant 2. And so the mistake a lot of people make is they look at the original angle to make the decision, but we need to look at where is it after it gets cut in half. So then again, I think the easiest thing to do is just multiply by 13 over 13 in here. And so when I do that, I'm going to have 13. The negative makes it a plus. That 13 cancels, so I've got 12. And on the bottom, I've got 26. So that's going to be radical 25 over radical 26. And of course, the square root of 25 is 5. And there it is. So if I do the cosine of theta cut in half, again, it's plus or minus the square root of 1 plus the cosine over 2. Again, very, very similar, but now we need to, again, think about where is theta cut in half. It was in quadrant 2, so this time the cosine of an angle in quadrant 2 is going to be negative. Right? So now this time I need to make sure I pick the negative. So I've got negative, and then all this is the same. 1 plus, I go back to the original angle, which was negative 12/13. And then on the bottom I've got 2. So that's going to be negative. So if I multiply by 13 over 13, I'm going to get, let me change back to orange here, 13 minus 12 over 26, which is negative 1 over radical 26. And again, then, when I'm doing the tangent, I think the easiest thing to do is, rather than have to use the tangent formula, since I already have the sine, right, and I have the cosine, then I might as well just divide the sine by the cosine. So if I take the sine of the angle cut in half, that's 5 over radical 26, and I divide it by the cosine, which would be negative 1 over radical 26, I just get negative 5. Right? The radical 26 cancel out. Boom, done. So if I've taken the time to find the sine and the cosine, getting the tangent, I can just use my old ideas. Okay, so I do have one other problem here I wanted to work through, because there's one of these, at least one of these on your check your understanding that you're turning in. And so I wanted to do this because it can seem a bit daunting when you first see this problem. Look, let's think through what this is actually saying, right? So again, we know that you can't take a cosine and distribute it, right? That doesn't work. So what we have to do is think about what this is saying. So we know that when I take inverse tangent of the ratio 4/3 is creating some angle A. And the inverse cosine of this ratio is creating some other angle B. And so really then what we have is the cosine of angle A plus angle B. And we know that that's a formula. That's the cosine of A, cosine of B, minus the sine of A, sine of B. So now we just need to plug all that in. So the question is, well, how do I get it? Well, this information is going to tell me, right? So if I bring this down and I draw a picture of that, I know that angle A, and we know that inverse tangent spits out answers over here. So I know that angle A is an angle that has a tangent of 4/3, right? So that makes this hypotenuse 5. And then angle B is an angle that has a cosine ratio of 5/13. So we know cosine spits out answers up here. So we have a cosine ratio of 5/13. So that makes this angle B, and this is 12. Right? So now that I've drawn my pictures, I can fill in. So essentially, it's like these problems up here, right, where I was drawing a picture. It's just they're asking it in a little bit different way. Right? So I've created the angle A and the angle B, right, using the inverse trig stuff that we learned back last chapter. So then the cosine of angle A is 3/5. The cosine of angle B is 5/13. The sine of angle A is 4/5. And the sine of angle B is 12/13. So then I would just get 15 over 65 minus 48 over 65, which is going to be negative 33 over 65. And there you go. Right? And that is it. So this one's going to be a very similar idea, right? This is saying, hey, this is some angle A. So what this is really saying is it's the cotangent of 1/2 A. Well, that's my half angle formula, right? And so if it's cotangent, we know that would be the tangent formula flipped. So if I go to the tangent formula is sine over 1 plus cosine. So that means the cotangent must be 1 plus cosine over sine. So then all we've got to do here is say, well, again, this is some triangle whose opposite is 11 and hypotenuse is 61. And so now I can find this using the Pythagorean theorem. And then once I have that, I can just plug it into this formula, right? And then I got my answer. So I'll leave that last bit to you. Okay, have fun with